Hello, today we're going to do notes for our Unit 8, Day 3. So Unit 8 is our unit on quadratics, and today we're going to be solving quadratic equations using square roots or completing the square. So you'll remember last class we actually factored a quadratic, and we know that using the zero product rule, if we have two factors, or even three factors, if you have factors that you're multiplying together and one of those factors is 0, then your whole product is going to be 0. So that was the concept that we used last class. This class, we're going to use some quadratic equations that can't be factored. And so if we can't factor them, we're going to have to figure out a different way to find our answers. So remember again that when we are finding the solutions, or when we are solving a quadratic equation, we're going to set the whole quadratic equation equal to 0, and we want to find the value for x, or the values for x that make that true. All right, so today what we're going to look at is we're going to look at quadratic equations that look like this format. So ax squared plus c equals 0. In this case, we have no bx term, so b would equal 0. Okay, so if we have ax squared plus c equals 0, then we can use square roots. We can solve this by using square roots. I'm going to try to focus again. I feel like that's not very focused. Okay, so here's what we're going to do. Our steps are, number 1, if necessary, set that quadratic equal to 0. Number 2, isolate the x squared term. And then number 3, we're going to solve for x by taking the square roots of both sides. All right, so here we go. All positive real numbers have 2 square roots. We have a positive square root and we have a negative square root. So in previous units, we have only asked for that positive or principal, that's how we called it, the principal square root. We have said pretty much we understand that there's a positive and a negative, but we just want the positive. Now that's all going to change, and now we know that there are 2 roots for our real numbers when we take the square root. So for this unit, we now are going to think about all of the solutions that we could possibly have. So here we are. We're going to solve the following quadratics using square roots. Okay, you're going to write any irrational solutions in the simplest radical form. So I'll try to remind you as we go through which of our solutions would be irrational. I'll try to remind you about that freeze. Okay, x squared equals 36. Well, you know that if we have that sort of a problem, maybe I'll make it zoomed in. I'll zoom it in. That seems a little better. Okay, if I want to solve this, I'm going to take the square root of each side, right? Because the square root undoes the square. All right, so I know that my answer is going to be x equals, now, in the past we would have just said 6, but now we know it can be positive 6 or negative 6, right? So here's how we write that. Plus, minus, like that. That means positive or negative 6. So my answer is x equals positive or negative 6. I could also say x equals negative 6, comma 6. And math space might actually want you to do that if you're doing homework in math space. Okay, this is because 6 squared equals 36. But also negative 6 squared equals 36. Okay, so this time we have 2 roots. All right, so solve the following quadratics by square roots. But I'm going to show you in this case, we also could have said x squared equals 36. I'm going to do this a separate way. This also means x squared minus 36 equals 0, right? Do you see a difference of squares? I sure do. So we know it's x plus 6 times x minus 6 equals 0, right? And if you'll remember from our last class, that tells us that we know x plus 6 must equal 0 or x minus 6 must equal 0. One or the other of those two factors must be 0. So x equals negative 6 or x equals positive 6. Okay, so we were able to work this both ways on this particular problem, but there will be some problems where we aren't able to factor, and so we're going to have to rely on using that square root method. Okay, so here I have 24 equals x squared over 6. And so what I'm going to do is multiply each side by 6. When we have a denominator that we don't want, we're going to multiply by that denominator to get rid of it, right? So I know 6 times 24 is 144, and that equals x squared. Okay, so I'm going to take the square root of each side, because the square root undoes the square. And I know that the square root of 144 can be positive or negative 12. So plus or minus 12 equals x. Or we would say, probably more commonly, x equals plus or minus 12. That's how most people are going to say it. Okay, so those are my answers for 1 and 2. Let's take a look at 3. Okay, number 3, I have the f of x equals 5x squared minus 500. So remember, oh, I've lost my cursor. Hang on 1 second. I found it. Okay. Sorry. Remember, the granddaddy of all rules when we are dealing with factoring quadratics or trying to solve quadratics is if there is a factor, a greatest common factor, we need to pull that out. Okay. Also, when I'm solving, so I'm not just factoring, when I'm solving, I'm going to set the whole thing equal to 0. Okay, so I'm going to do two things at once. I'm going to say f of x I know is going to be 0 because I'm looking for when the whole output equals 0. And I'm going to pull out that 5. So I have 5 times x squared minus 100. Oh, looky there. I have a perfect, a difference of squares again, yeah? Okay, so if I want to right now, I can divide each side by 5. Or I can leave that 5 there. I'm going to divide each side by 5 now. So 5 over 5, 0 over 5. 0 divided by 5 is still 0, right? So I have 0 equals x squared minus 100. And that means 0 equals x plus 10 times x minus 10. And so 0 has to equal x plus 10, or 0 has to equal x minus 10. I'm saying those weirdly. X plus 10 equals 0, or x minus 10 equals 0. We know that x equals positive or negative plus or minus 10. That's our answer. Okay, you can, and then I don't know why I did that. I just solved that by factoring, and I'm trying to make a point of solving by square root. So let's do this as the square root way. Okay, I am going to back myself up, and I have f of x equals, let me just start that whole problem over. F of x equals 5x squared minus 500. We know that we've got f of x is 0, because that's how we solve. 0 equals 5x squared minus 500. I'm going to add 500 to each side. 500 equals 5x squared. Divide each side by 5, and I have 100 equals x squared, yeah? If I take the square root of each side, then the square root of x squared gives me just x, so I know x equals, I'm going to again say both of the answers here, positive or negative, plus or minus 10. So sorry for doing that the old-fashioned factoring way. Factoring is usually more efficient for me, but you're going to have to decide for yourself which way you prefer. If it is factorable and I happen to see what the factors are, I'll usually factor. But if you can't factor, you're going to have to use the square root. So let's see if we can get to a point where we have to do that. Hint, hint, maybe on number 4. 3x squared plus 15 equals 0. This is in the format that we're talking about today. I have, where is ax squared plus c equals 0, right? My b value is 0. So 3x squared plus 15 equals 0. I'm going to go ahead and set that up so that it's 3x squared equals negative 15. And I'm trying to solve, right? So I'm going to divide each side by 3. I have x squared equals negative 5. So I'm going to take the square root of each side. Whoa, okay, so the square root of x squared is really x, but am I allowed to take the square root of a negative number? Not in this class, okay? We can't take the square root of a negative number. We have, say, so we're going to say no solution in this class. There is a solution that involves the letter I, and so since we could, in a different class, find a solution, we can say no real solution in this case. Okay. Let's look at our next couple problems. Forgive me, my allergies are absolutely awful today, so that's why you get me sniffling through these. All right. 5x squared minus 45 equals 0. First thing I'm going to do is go ahead and put this so that I'm going to isolate my x squared. So 5x squared equals 45. I'm going to divide each side by 5, so I have x squared equals 9. And now when I take the square root undoes square, so I have x equals, remember I want both roots, so plus or minus 9. Excuse me, oh my gosh, who's making up math now? That would be me. Sorry, the square root of 9 plus or minus 3. Glad I caught that before I moved on. Okay, square root of x squared is just x, and the square root of 9 is positive 3 or negative 3. Okay, over here, well, right now I have a bit of a mess, but when I add 16 to each side, I'm going to get x squared equals 75. Okay, I'm going to take the square root of each side, so I get x equals the positive or negative square root of 75. Now, I can simplify square root of 75, so you have to think back to this unit that we had. I know that this is x equals positive or negative of the square root of 25 times 3. Yeah? And so I know that this is x equals plus or minus 5 times the square root of 3. That's my final answer, okay? It is true that x equals positive or negative times the square root of 75. So the positive square root of 75 or the negative square root of 5. Can't say my words, I'm sorry. X equals the positive square root of 75 or the negative square root of 75. But we have a better way, a more meaningful way to write that answer. So we're going to say x equals plus or minus 5 roots of 3. This really does mean x equals negative 5 roots of 3. Or x equals positive 5 roots of 3. There will be some cases where you actually might use a calculator to estimate what this total would be. So you would put 5, make it negative, times, and then do square root of 3, and you could round to the nearest hundredth or something, but I'm not asking you to do that right now. Okay, let's keep on going. I have 1/2 x squared minus 11 equals 25. I'm going to add 11 to each side. So I have 1/2 times x squared equals 36. Well, I'm going to multiply each side times 2 because let's not make that look like a squared. Times 2 because I'm getting rid of that 1/2. So I know x squared equals 72. Okay, or 36 times 2, right? It might be just as helpful to leave that broken up. When I take the square root of each side, I know that x equals positive or negative square root of 72. But we know the square root of 72 is really positive or negative 6 times the square root of 2, right? If I simplify that, it's positive or negative square root of 36 times 2, all under the house. Okay, so you have to think back to our previous units. Okay. Number 8, y equals x squared minus 150. Well, don't let that throw you, right? We know y, or the f of x. We know our final output has to be 0, so we're going to say 0 equals x squared minus 150. I'm going to add 150 to each side, so 150 equals x squared. Take the square root of each side. So I know I need positive or negative square root of 150 equals x. And I have to break up the square root of 150, positive or negative, the square root of 25 times 6. That all equals x. And if you didn't know that right off the top of your head, you just want to keep kind of dividing by perfect squares or figure out your roots, all of your factors with a factor tree of 150. So remember, you can do this. 150 is really 2 times 75. 75 is really 25 times 3. 25 is 5 times 5. And so I see I have a pair, right? The pair of 5s means that I get to pull a 5 outside of the house. I'm left with 2 and 3 inside the house. 2 and 3. 2 times 3 is 6, so that stays in the house. Okay, that's not the only way to do it. That's just one of the many ways. Okay, now That was solving using just finding the square root of each side. So now we're going to do this a different way. We're going to solve our quadratic equations by completing the square. This is an extension for Algebra Honors class, and so I guess I have to shrink down a little bit. Solving quadratic equations by square roots only works when we are able to shorten down to bx equals 0, simplify down to bx equals 0. No, I'm not saying those words right. Sorry. It only works when our b value is 0, meaning that bx is 0 and we have no bx term. Okay. If, however, we come across a quadratic equation where bx is not equal to 0, but that still can't be factored, we have a different way that we're going to try to solve. Okay? So, let's look. Factor the perfect square trinomial, and then solve by square roots. That's what we're going to do first. So I'm going to factor. I see that it's a perfect square trinomial, and I have a subtraction sign in the middle, so I know I'm going to have x minus 6 all squared. That equals 0, and so square root of each side, I know x minus 6 equals 0, because the square root of 0 is 0, yeah? And so I know x equals 6. That's it. That's what I get. Okay, so, give me 1 second. If I have x squared minus 14, x plus 49, I see that my first and last are perfect squares. So remember how to see if something's a perfect square trinomial. I take the square root of the first and the square root of the last and multiply them together. So I get 7x, and double it is 14x. So that's, I know that I've got a perfect square trinomial, but it's going to be x minus 7 all squared. That equals 0. So I know is x equals positive 7. It's the only option that I have there. Okay. If I took the square root here and the square root, I would get x minus 7 equals 0, and that's how I got x equals 7. Okay. So that's just kind of a reminder of factoring, right? Most quadratic expressions are not going to be perfect square trinomials. Completing the square is the process of finding some constant that we can add to x squared plus bx to make it look like a perfect square trinomial. So we are going to artificially give ourselves this perfect square trinomial, right? So, all right, I'm going to ask you to look at this pictorial representation with me for a moment, okay? If I have x squared plus bx, you know that I get x squared by having x. Remember, if we had that outer bar times x, right? And then it's going to be some number b times x. So I would have this x over here as well. You know, x times b. Okay. So that does not give me a square. You can see that that would give me a rectangle. I want to artificially make myself have a square. So I'm going to split b in half. I'm going to split it in half. So I'm going to say b over 2 times x, right? b over 2 times x. And I'm going to say b over 2 here times x. Okay, I still have, in the end, bx, but I just made it look different. And if you notice, there's this gaping hole right here that I can put a constant in. I can put just a little constant in. So I have to figure out what is the constant that I get to put in that's going to make this be a perfect square. All right? So this was x squared plus bx, this whole picture. And this over here is x squared plus bx plus something that is b over 2 squared. b over 2 squared. So let's try to make sense of that. So hopefully actually working with numbers will, maybe we can come back to that pictorial representation and help make sense of it. Or maybe I just need to find different resources to help you understand that. All right, steps for solving quadratic equations by completing the square. So we're looking for that constant we can put in there that's going to give us a perfect square trinomial. First, we're going to do this when our leading coefficient is 1, okay? So we're going to rewrite our quadratic in the form ax squared plus bx equals c. Notice that I've got my c out isolated, okay? Then I'm going to calculate b over 2 squared. Okay, so whatever my b is, I'm going to take half of it and then square that whole amount. And I'm going to add it to both sides. Then you'll see that I get to factor a perfect square trinomial. Well, then you'll see that I have a perfect square trinomial that I can factor. And we're going to take the square roots of both sides. So let's do it, see what it looks like. Okay, I have x squared minus 12x plus 27 equals 0. So you're just going to trust me that we're not able to factor that. So I'm going to rewrite this so that it's x squared plus bx equals c. Okay, I'm going to rewrite it. I'm subtracting 27 from each side. I have x squared minus 12x equals negative 27. Okay, so in order to complete the square, I've got to figure out some number that's going to give me a perfect square trinomial. I've lost my cursor again. There it is. Okay, so if I want to have a perfect square trinomial on the left side of my equal sign, that would be x squared minus 12x plus 36, right? Now I have a perfect square trinomial, right? Half of my middle term squared, okay, equals negative 27. Now, I just added 36 completely arbitrarily, one might say. So if I add 36 to that side, I have to add 36 to this side, because math is always fair. So now I really have the same information, I'm just making it look different. Okay? This, I know, is x minus 6 all squared, and it equals whatever 36 minus 27 is. 36 minus 27 is 9. Well, isn't that convenient? I'm going to take the square root of each side. Take the square root of each side, right? Square root undoes squared. So I just have x minus 6. And the square root of 9, now that we are this far in our unit, this far in our year, we're going to say it's positive or negative 3. Well, I know that I can figure out what x is, okay? I'm going to add 6 to each side, but here's what's going to happen, okay? I've positive or negative 3 plus 6. So what's going to happen is I'm going to rearrange this. I have x equals 6 plus or minus 3. See how I'm writing it? That really means that I have x equals 6 plus 3 or 6 minus 3, right? X equals 6 plus or minus 3. Sorry, 6 plus or minus 3. So it equals 9 or it equals 3. Those are my options. X equals 6 plus 3 or x equals 6 minus 3. Okay. I don't know if MathSpace wants you to put it in order, 3, then 9 in numerical order. I don't know about that. But if it doesn't like 9, 3, try 3, 9. Okay, x squared plus 4x minus 5 equals 0. We can't factor it, so just assume that we worked hard to try to use the x puzzle and find factors. We couldn't do it. So we're going to complete the square. I'm going to say x squared plus 4x equals 5, right? My first step is to set it so that it's x squared plus bx equals c. Now, only on the left side, what would I have to add to make that a perfect square trinomial? X squared plus 4x. To make it a perfect square trinomial, I take half of my middle term, so 2, half of the b, so I have 2 and I'm going to square it. So I'm going to say plus 4. Now if I add 4 on the left side of my equal sign, I have to also add 4 on the right side. See how I did that? Okay. Now I'm going to factor because now I can. And I have x plus 2 all squared equals 5 plus 4, which is 9. Square root of each side. Square root undoes square. So I have x plus 2 equals plus or minus 3. Again. So that means x equals, I'm going to put the 2 first because it makes more sense to us. Negative 2 plus or minus 3. Which means x equals negative 2 plus 3, so that's 1. Or it equals negative 2 minus 3, which is negative 5. See, and as is often the case, sometimes doing these problems with actual numbers makes more sense than trying to use just the rules and the pictures. All right, x squared minus 2x minus 4. I could not come up with any two numbers that multiply to give me negative 4, but add to give me negative 2. I couldn't do it. And so I'm going to complete the square. That means I'm going to start out by saying x squared minus 2x equals 4, right? Put it in ax squared plus bx equals c. Now on my left side, I'm going to make that a perfect square trinomial. So I'm going to say x squared minus 2x, take half of negative 2, or half of 2 is 1, sorry, so, or negative 1, either way. We're going to take half of 2, and we're going to get 1, and 1 squared is 1, so we're going to say plus 1 here. If I add 1 to the left, I have to add 1 to the right. Okay, now I'm going to say this is x minus 1 squared, and it equals 5. Well, this time I don't have my fancy 9 that I happen to have in both other examples, right? The square root of 9 we could find was plus or minus 3. It's okay, I still can do this method because I'm still going to take the square root of each side. Okay, square root undoes square. So I'm left with x minus 1 equals plus or minus square root of 5. So I'm going to add 1 to each side, and I'm going to say x equals 1 plus or minus the square root of 5. If you are told that you can keep your answer in radical form, you do want it to be the simplest radical form. You wouldn't want to leave me a square root that could be simplified. But if you are told to leave in radical form, then this can be your final answer. It also means x equals 1 plus the square root of 5, or 1 minus the square root of 5. And if you had to use a calculator to figure those out and estimate, using a decimal, maybe round to the nearest hundredth or something, you could do that. But we don't have to because we are told that we can leave this in radical form. Okay, number 4. X squared plus 16x plus 46 equals 0. I'm going to put it in x squared plus bx equals c format. As always, if you people who are watching catch me make a mistake, if I forget to make something negative, by all means let me know. I think I'm still doing okay today, but just in case if I ever mess up, if you're in class with me this year, by all means come by. Even if you're not my student, this is Mrs. Thomas talking, and you might get a Jolly Rancher for it. Okay, it looks like I remembered, though, to make that negative 46, so here's what we're going to do. We're going to take half of 16 and square it. So I have x squared plus half of 16 would be 8. So I'm keeping 16x, but I'm going to take half of 16, and that's 8, so I'm going to say 8 squared is 64. If I add 64 to the left, I have to add 64 to the right. Again, all I did was I made myself my very own perfect square trinomial so that I can factor it. I know that's x plus 8, all squared, and now I know that it equals 64 minus 46, which is 18. Okay, I'm going to take the square root of each side, and so square root undoes square. So I have x plus 8 equals plus or minus the square root of 18. But remember I said simplest radical form, so I know that's 9 times 2, right? Yeah, so watch, it's going to be x plus 8 equals plus or minus 3 roots of 2, because I simplified my radical. And now I want to get x all alone, because that, in fact, is our point. The whole point is we want to find what x values will plug in and make our information true. So we're going to say that x equals negative 8 plus or minus 3 times the square root of 2. Again, I have 2 roots. This means negative 8 plus 3 roots of 2. And the other option is negative 8 minus 3 roots of 2. Okay, that's what that means, is I have 2 answers. Okay. You are welcome to try the next couple on your own. Just pause the video. I'm going to zoom in just a little bit. Go ahead and pause and then come back and see what you get. Okay, so the first thing I want to do is get myself looking like ax squared plus bx probably equals c. Sometimes if I don't know what's going to happen, maybe I just put it into ax squared plus bx plus c equals 0 format. Maybe I would do that first. And make sure, so standard form, and make sure that it's not factorable. This one's not going to be factorable, I'm telling you right now. So x squared plus 7x plus 6 equals 66 minus x. I'm going to add x to each side, so I have x squared plus 8x. And I'm going to subtract 66 from each side. So that's negative 59. That all equals 0. I'm in standard form here, right? I subtracted 66 from each side and I added x to each side, and so I have the whole thing set equal to 0. Now I'm looking for two numbers that multiply to give me negative 59 but add to give me 8, and those don't exist. It's not factorable. So our rules today for completing the square, we say that we're going to make it look like x squared plus 8x. I'm going to leave myself space here. And I'm going to say the other side is 59 because I'm just adding 59 to each side. I'm leaving myself space here. This is actually a good technique for giving yourself room to work. I want to complete this square. I want to have a perfect square trinomial on the left side. So I'm going to take half of b, that's 4, and square it. That's going to be 16. So I left in that empty space, I just added 16. So if I add 16 to this left side of the equation, I have to add 16 to the right side of the equation. All right, and so now we're going to solve this way. If you didn't pause before to work through the problem, why don't you try now to see if you can do this on your own? Pause and then come back. I'm going to factor. I have x plus 4 is all squared, right? That equals 59 plus 16. That's 60, 75. Is that what you get? That's what I get. I'm going to take the square root of each side. Square root of each side. Square root undoes square. So I know x plus 4 equals plus or minus 5 roots of 3. I just did 2 steps in one, okay? I took the square root of each side, but I also made that I simplified that radical. Okay, so I'm going to subtract 4 from each side because I ultimately want to get x all by itself. So x equals negative 4 plus or minus 5 times the square root of 3. Those are my answers. Negative 4 plus 5 roots of 3 and negative 4 minus 5 roots of 3. Okay, over here I have x squared minus 2 equals 6x minus 3. I'm going to first put everything over so that I end up with standard form. Okay, so I'm going to subtract 6x from each side. And I'm going to add 3 to each side. So negative 2 plus 3 is just 1. That all equals 0. Okay, now I'm going to put it in ax squared plus bx equals c format. Ax squared minus 6x equals negative 1. Okay, I actually can make a perfect square here, right? So I'm going to say x squared minus 6x. I forgot to leave myself a space. Take half of b is 3, right? And 3 squared is 9, so we're going to add 9. And if I add 9 on the left, I have to add 9 on the right. So I know that this is x minus 3 all squared equals 8. Okay, and we're going to take the square root of each side, and so I have x minus 3 equals the square root of 8, which is really 2 roots of 2, plus or minus. X equals, I'm going to add 3 to each side, so 3 plus or minus 2 times the square root of 2. Okay, when I simplified that perfect, oh, you can't see what I wrote, I'm sorry, x equals 3 plus or minus 2 roots of 2. So when I simplified that perfect square trinomial and made it x minus 3 all squared, if that's something that you're still needing reminders on, you can always go back to any of the Unit 7 notes and double check how to do that. And so just so you know, if you want to look up how to do this, we were factoring perfect square trinomials. Perfect square trinomials. I think in our notes for Unit 7, we were factoring special cases because we had perfect square trinomials and we had difference of squares. Okay, so if you need reminders, go back to Unit 7 and look at your notes on that, okay, on factoring perfect square trinomials. All right, nearly done. All right, please try these problems on your own first, because watching somebody else do them usually is easy to follow along with. And you probably are nodding your head, and even if you're writing things down as you're watching, it's not the same as trying to solve it on your own from scratch. So try these on your own from scratch. That means pause the video and then come back and see if you got it right, or if you're really struggling, try it on your own, and if you're really struggling, you can come back and watch the video. But ultimately, you want to be able to do these problems on your own. Mixed practice. We're going to solve the following quadratic equations. Use each of the following methods once. So we're going to use graphing, factoring, square roots, and completing the square. Okay, we're not always going to ask you to use a specific method, but we are going to give you hints on which methods might be good ways to solve these problems. So number 1, it says solve by graphing. Okay, I have the x squared minus 12x plus 36. If I'm solving by graphing, the first thing I want to do is find my axis of symmetry. So I know that that is when x equals negative b over 2a. Remember, x is going to give us a vertical line, right? Because we have a Vux situation here. So we're going to have some value for x that's going to give us a vertical line. That is our axis of symmetry. So in this case, a equals 1, b equals negative 12, and c equals 36. So my axis of symmetry is going to be negative b, negative of negative 12, over 2 times a, which was 1. So it's 12 over 2, or 6. X equals 12 over 2. X equals 6. So my axis of symmetry is x equals 6. Okay, so here I am, x equals 6. This is my axis of symmetry. That means my vertex is going to be right on that axis of symmetry, right? And I know my vertex must be, it's always going to be some xy because it's an ordered pair. I figured out the x is 6, so I have to figure out what's the y part. Well, I go back up here, and if x equals 6, I'm going to plug that in. Plug it in. So it's going to be 6 squared minus 12 times 6 plus 36 equals 0. I know what x is, and so I plug that in, and I'm going to figure out what is y. Sorry, equals y, because I want to find y. Okay, so 6 squared minus 72 plus 36. I have 36 minus 72 plus 36. Okay, 36 minus 72 is negative 36, plus 36 is 0. So 0 equals y. Remember, up here, when we say we're setting that equal to 0, I'm looking for solutions, or I'm looking for the zeros, but it means I'm setting the whole function equal to 0. So if I know what my x value is, I can plug it in and find the y value. In this case, the y value happened to be 0. It's not always going to be that. My vertex is at 6, 0, so 6, 0, right there, right? I can see that this is a positive leading coefficient, so I know that my parabola is going to be going upwards like that, right? And so I need to come up with a couple of points to put on there. So I'm going to give myself an xy table. I'm going to plug in some y's I'm really willing to work with, some x's that I'm willing to work with, excuse me, and I'm going to find out the y value. Okay, so I'm going to say if x is, how about 3? If x is 3. If x is 3, when I plug it in, I want to find out what is the answer to that. So, okay, so we are saying that this is x is 3. So the f of 3, that's the best way to say that. Okay, the f of 3. When x is 3, then I'm going to have 3 squared minus 12 times 3 plus 36. That's 9 minus 36 plus 36 is just 9. The f of 3 is 9. When I plug in 3, my output is 9. So I have that ordered pair. I'm going to find the f of 4. F of 4. When I plug in 4 every time I see an x, I get 4 squared minus 12 times 4 this time, plus 36. And that ultimately equals 4. Okay, 16 minus 48 plus 36 equals 4. So I plug in 4, I get 4 back out. And if I plug in 5, 25 minus 12 plus 36 is going to equal 1. Okay, so I have 3 different points. Okay, I have a 3 and 9. 3, 9 is one of my points. Now remember, this is my axis of symmetry, so I can whomp, whomp, whomp to the axis, whomp, whomp, whomp to the other side, because I know I have to have a mirror image. If x is 4, y is 4, right there. So I know that if I have a point whomp, whomp, 2 to the left of my axis, I know whomp, whomp, there's 1, 2 to the right of the axis. I actually could draw my parabola now, but since I calculated out, if x is 5, x is 5, y is 1, and I have a mirror image, and so this is my parabola. Right? And I have a minimum down here. Okay, solve by graphing. You want to give us the axis of symmetry, you want to give us the vertex, and a couple of points. Okay, number 2. Oh, sorry, let's come back here. Sorry. So my solutions, I want to know where did I cross the x-axis or where did I touch the x-axis. I only touched it exactly, right? So I know that the only x value I have is when x equals 6, right? Right there. That ordered pair is 6, 0. So the x value is 6. All right. Negative x squared plus 25 equals 0. Which method might I choose? I might choose square roots. Okay. I have no bx term, or b is 0. So that's why I might choose that one. Okay. So I have negative x squared equals negative 25, right? Because you want to isolate your x when you can. So I'm going to multiply each side by negative 1 or divide each side by negative 1, doesn't matter. So I have x squared equals 25. And take the square root of each side. Square root undoes squared. So I know x equals positive or negative 5. And that's my answer. Okay, so let's take a look at the next one. We're going to do 2x squared minus 14x minus 60 equals 0. Probably the first thing I would do is see if I can factor it. I can do completing the square this way also, but I might try to factor. But granddaddy of all rules, if there's a greatest common factor, we want to pull that guy out. So we will. 2 times x squared minus 7x minus 30 equals 0. Okay, so now I'm going to see if I can factor. Okay, I can keep that 2 on the outside. I'm going to see if I can factor this. I need 2 numbers that multiply to give me negative 30, but they add to give me negative 7. Well, 10 and 3 seems like that might fit the bill. Let's try negative 10 times 3 is negative 30. Negative 10 plus 3 is negative 7. You can't see my X puzzle, I'm so sorry. 2 numbers that multiply to give negative 30 but add to give negative 7. So I see my magic numbers are negative 10 and 3. So I'm going to have in one binomial x minus 10 and in the other binomial x plus 3. That all equals 0. So I do have 3 factors. 2 times x minus 10 times x plus 3. See how I have 3 different factors? So that matters if I'm graphing, because I don't want to lose my 2 if I'm graphing. But if I'm just looking for the x-intercepts, I can go straight to what numbers I would plug in that would make either of these binomials equal to 0. So here's how I think about it. I'm going to divide each side by 2, yeah? And 0 divided by 2 is still 0. So now I know x minus 10 times x plus 3 equals 0. So that means that x minus 10 equals 0 or x plus 3 equals 0. You don't have to write it all out like this because I know a lot of you can see very quickly that x obviously equals 10 or negative 3 because I plug in 10, 10 minus 10 is 0, plug in negative 3 plus 3 is 0. Holy moly, 45 minutes is a long video. Okay, so in this case, I just was able to factor. If I had tried to factor, though, and if I couldn't find factors, I probably would have moved on and completed the square. Okay, this means that my last one is probably going to be a completing the square problem. And so let's go ahead and do that. Remember, we say x squared plus 6x. I'm going to leave myself space equals 71 because you want ax squared plus bx equals c. When I'm completing the square, I'm going to take my b value and split it in half. So half of 6 is 3, and then square that. So I'm going to say 9. If I add 9 to the left, I have to add 9 to the right. That's the rules. And so now I'm going to factor x plus 3 all squared equals 80. Let's take the square root of each side because square root undoes square. And so I have x plus 3 equals positive or negative square root of 80. Well, square root of 80, I know that I can simplify. It's actually 16 times 5. The reason I'm doing that is now I can say x plus 3 equals positive or negative 4 roots of 5. I'm nearly done, right? I'm using completing the square. Okay, so I'm going to say x equals, I'm taking 3 away from each side, so it's negative 3 plus or minus 4 times the square root of 5. There you go. Those are our 2 answers, and I'm just pretty sure I got that right. Negative 3 plus or minus 4 roots of 5. Thank you so much for watching. That was a really long video, but that's partly because I'm taping at home, so I didn't have announcements interrupting me or people walking into the classroom. So yay. Thanks for watching. Good job, and look for homework in Math Space.